Hello everyone, welcome to Dakshana e-classroom program, and this is a solution video for paper MZT04 for NEET part physics. So let's continue with the sequence in questions. So here we have question number 1. A transistor connected in common emitter configuration contain load resistance of 5 kilo ohm and input resistance of 1 kilo ohm. If the input peak voltage is 5 millivolt, the current gain is 50, then voltage gain is. Okay, so here question number 1. So our output is 5 kilo ohm, our input is 1 kilo ohm, and it's also given the input peak voltage delta V in input is equal to 5 millivolt, and current gain is also given as AI is equal to 50. Then you are asked to find voltage gain. So AV is equal to, we can write simply I into R output by R input, no need for this. That's equal to 50 multiplied by, this is 5 kilo divided by 1, that's 250. This is the voltage gain matching with option number 2. Question number 2. The part of the transistor which is most heavily doped to produce large number of the majority carrier, that's called simply emitter. So conceptual based. Question number 3. The energy of radiation emitted by LED. So LED में मतलब radiations basically कैसे emit करते हैं वो आपको अगर समझ में आता है, it's also like simple theoretical questions. So it's equal to or less than the band gap of the semiconductor, matching with option number 4. Question number 4. So here radioactive nucleus X, mass number A and the atomic number Z, emit 3 alpha particle and 5 beta particle. The ratio of number of neutron to that of the proton in the product nucleus will be. So initially atomic weight number and atomic number, that's A and Z, 3 alpha 5 beta. Because of 3 alpha, the change in atomic weight, so A prime will be of the nucleus, product nucleus will be A minus 6 because of it's plus 5. This 3, so it's 6 plus 5. This is basically A minus 1. And Z prime will be basically because of it's mistake actually, because of 3 alpha it will be like 4, because of, so it will be 12 plus 5, so it's coming out to be minus 7. And this will be like Z, I think I just did mistake. Because of beta there is no change actually, so it will be simply A minus 12. And because of Z, in Z there is change because of beta, but because of beta no change in atomic weight, because simply proton getting converted into neutron, neutron getting converted into proton, there is no change in atomic weight. So this, and Z prime will be like Z minus, because of this 6, because of this plus 5, so it's basically Z minus 1. Number of neutron plus proton, this is the number of proton, so number of neutron is equal to A minus 12 minus Z plus 1, that's A minus Z plus minus 11. So number of neutron divided by number of proton, that's equal to Z minus 1. It's matching with option number 4. Question number 5. Binding energy per nucleon versus mass number curve of nuclei is shown in the graph. W, X, Y, Z are 4 nuclei indicated on the curve. The process that would release the energy. For this you need to understand, in a like process, if the product nucleus has higher binding energy per nucleon, then the energy will be released. If it is moving towards lower binding energy per nucleon, energy will not be released. So let's say in case of 1, Y is getting converted into 2Z. So Y, if it is going to 2Z, you can see the binding energy per nucleon is decreasing. It's not possible to release the energy. Second, W getting converted into X and Z. So in W, one X product is having higher binding energy, but Z is having lower binding energy. Overall binding energy may not be like released. So we can just see the best available options. So next case is 3, when W is getting converted into 2Y. So in this case, definitely like binding energy per nucleon is increasing for the product. So definitely energy will be released. So correct answer will be 3 for question number 5. Next, question number 6. So here, X-ray tube operate at 20 kilovoltage. A particular electron loses 5% of its kinetic energy to emit X-ray photon at first collision. The wavelength corresponding to this photon. So let's say the energy of that 20 into 10 to the power 3 into 5% of this, 5 into 10 to the power minus 2 into, so electron, this is the energy of, and this is getting converted into H into nu. We are need to get the wavelengths hc by lambda. So this implies lambda is equal to hc divided by, this is 20 into 10 into 1.6 into 10 to the power minus 19. Substituting values and solving, we get H is equal to 1.24 nanometer. This is the answer matching with option number 1. Question number 7. In a Bohr model of hydrogen atom, electron is revolving around a proton p with the velocity v. If r is the radius of the orbit, m is the mass of the electron, and epsilon naught is the permittivity of the vacuum, and then the value of the kinetic energy of the electron. So by like balancing the centripetal force, we can write mv square by r for electron is equal to total, this is E square by 4 pi epsilon naught into R square. 1 R getting cancelled, so this is left with 1 R. This is mv square divided by 2 is the kinetic energy. This is divided by 2 here also. So kinetic energy is coming out to be E square by 8 pi epsilon naught into R. This is the answer matching with option number 2. Next, question number 8. So here, when a certain metal surface is illuminated with light of frequency nu, the stopping potential for the photoelectric current is V0, and when the same surface is illuminated by light of frequency nu by 2, the stopping potential is V0 by 4, the threshold frequency for the photoelectric emission. So in this case, in one case, it's, let's say frequency is nu, so h nu minus threshold work function, this is phi, is equal to E V0 by 2. It's E V0, stopping potential energy. Next case, E nu by 2 minus phi, work function is remaining same. This is E V0 by 4. By adjusting these two, subtracting this to this, we are getting actually h nu by 2 is equal to 3 E V0 by 4. This implies E V0 is equal to 2 h nu by 3. We got this. Substituting here in this, so phi is equal to what? H nu minus this 2 h nu by 3, that is h nu by 3, and this is equal to h nu threshold is coming out to be v by 3. That's matching with option number 2. Question number 9. Here it's in case of linearly polarized light, the magnitude of electric field vector. So in case of linearly polarized light also, only the vibrations of electric fields are limited to one particular direction. Remaining things like the variation of electric field like sinusoidal, it's still remain same. So we can write changes periodically with time will be the right answer. Question number matching with option number 4. Next, question number 10. So here, emitter base junction of a transistor biased while collector base junction, it's like standard. So emitter base junction is always forward bias, it's like generally talking about active mode, and collector base junction is reverse bias. So it's matching with again 4 theoretical question. Question number 11. Here it's saying focal length of objective and eyepiece in astronomical telescope are 50 and 2 centimeter. For normal adjustment, magnifying power and length of the telescope. So magnifying power is f objective by f eyepiece, 50 by 2, that is equal to 25, and the length is f objective plus f eyepiece, that is 52 centimeter, and that's matching with option number 2. Next, question number 12. So here, one face of rectangular glass plate 6 centimeter thick is silvered, and an object held 8 centimeter in front of the first phase. Okay, an object held 8 centimeter in front of the first phase form an image 12 centimeter behind the silvered phase. So here glass slab, this phase is silvered, its thickness is 6 centimeter and 8 centimeter, and we are getting the final image here at 12 centimeter. Simply writing that this effective distance equal to 12 centimeter, and solving we get actually mu for this is equal to 1.2, matching with option number 3. Next question number 13. Position of fourth image of the mirror M1. So here you need to check it actually. So this is mirror 1. It's here placed at 6 centimeter. This is 15 centimeter. So image due to this first image will be at here 6 centimeter. This will form image here at 15 centimeter. Now this is, let's say, 1, this is 2. So this image will act as an object for this, so it will be like 50, 30, total 36. Next will be like here at 36 centimeter, and similarly this will act like an object for this mirror, so it will be like 15, 6 plus 6, it's 27. So it will be, image will be here at 27, and so on. We are checking the fourth image comes at 78 centimeter. So that's matching with option number 3. Question number 14. Displacement current is same as, it's simple conceptual question, is same as is not a conduction current but is caused by time varying magnetic field, time varying electric field. Fourth is the right answer. Next question number 15. Power dissipated in an AC circuit is 0 if the circuit is either completely capacitive or purely inductive or purely capacitive, in both cases. So third is the right answer. Next question number 16. In step up transformer, the turn ratio is 1:2. A Lagrange cell, you must remember it's a DC cell, is connected across the primary. The voltage developed in the secondary would be 0 because transformer doesn't work for a DC. And next question here, magnetic field at point, this is question number 17. So magnetic field at point M of the given current distribution. So here we have like this current 3 ampere, another current here which is 9 ampere. This is point M. This distance is given as 6 meter. This is 2 meters. So by applying Ampere's law, due to this the magnetic field will be like inward. Due to this it will be outward, and we can say this will be dominating. So we can write integral B dot dl due to this will be like, it will come out to be mu naught into I, that is 9 ampere, divided by 2 pi into R2 minus, due to this is 3 mu naught divided by, this is 2 pi into R is 6, and solving it we get it's actually 2 mu naught by pi inward. That's the answer, matching with option number 3. Next question number 18. So here a current I is uniformly distributed over the cross section of the long hollow cylindrical wire of inner radius R1 and outer radius R2. Magnetic field B varies with distance from the axis of the cylinder. Cylinder is like this. So current is flowing in this. So inside magnetic field will be 0 if you are starting from here to R1. In this region there will be magnetic field varying, and because it's inside so it will not exactly, we can calculate it. It will vary like this actually, mu naught into I divided by, this is 2 pi R into net I enclosed, we need to write it's basically, I'll write R square minus A square divided by, it's B square minus A square. So this will be, so here you can say this is the variation, so it will increase. So then after up to here it's 0 increase, and then after that it will be inversely proportional to R, so it will be simply like this, so which is matching with option number 2. Question number 18. Next question number 19. Two electrical bulb marked 40 watt and 220 voltage and 60 watt and 220 voltage when connected in series across the same voltage supply 220 voltage. The effective power is P1, and when connected in parallel the effective power is P2. Then the ratio of P1 by P2. So let me write the resistance. R1 is equal to V square 220 square by 40. R2 is equal to V square 220 square by 60. connected in series, then R effective will be R1 plus R2, and that's coming out to be 220 square into 100 divided by 2400. So 220 square divided by 24. Then power P1 is equal to V square by R effective, R1 plus R2, that's coming out to be 24 watt. Okay, P1. P2, it's connected in parallel across both, the voltage will be same, 220 voltage, so it will be like 40 watt plus 60 watt, it will be 100 watt. So the ratio of P1 by P2, it's coming out to be 0.24. That's the answer, matching with option number 3. Question number 20. Two batteries are connected as shown in the figure, then the reading of the voltmeter V. So here it's also simple, this and this is the voltmeter connected here. So here current will be flowing this way, and this is 10 volt, this is 8 volts, so total it's 18, and this is 3 2, it's so I is equal to 18 by 5. Potential difference across this is basically 3 into minus 3 into 18 by 5 plus 10, that solving we are getting it minus 0.8 voltage. Answer matching with option number 1. Question number 21. Okay, figure shows 2.0 volt potentiometer used for the determination of internal resistance of a 1.5 volt cell. The balance point of the cell in open circuit is found to be at 76.3 centimeter. When a resistor of 9.5 ohm is connected used in external circuit of the cell, the balance point shifts to 64.8 centimeter of the length of the potentiometer wire. The internal resistance, it's simple like a formula based question. Internal resistance is given by R into L1 by L2 minus 1. Substituting everything here, R is given as 9.5, L1 it's given as basically 76.3 divided by 64.8 minus 1. Solving it, we are getting R is equal to 1.7 ohm is the internal resistance, matching with option number 1. Next, question number 22. Energy required from a battery to charge a parallel plate condenser of plate separation D and plate area of cross section A such that the charged surface charge density on the plate will be so sigma. So then Q is equal to sigma into A, and then energy required to supply is equal to Q square by 2C is only for capacitor, some half energy is lost, so Q square by C. So this is Q square by sigma square A square by A epsilon naught into D. So 1A gets cancelled. This is the answer, matching with option number 2. Next, question number 23. Alright, so two material of dielectric constant K1 K2 are introduced to fill the space between the two parallel plates of the capacitor as shown in the figure. The capacity of the capacitor is, so here C effective will be like both are in parallel, so it will be basically A epsilon naught K1 by, this is A by D plus A epsilon naught K2 by 2D. Solving, we are getting its matching with option number 1. Question number 24. Okay, with reference to the figure shown below, the electrical potential of it's a simple formula based problem. So here potential is given by K P bar dot R bar divided by R square, which is matching with option number 3. K is 1 by 4 pi epsilon naught. And next, question number 25. Here, if a unit charge is taken from one point to another over an equipotential surface, equipotential, no potential difference, no change in potential energy, so work done is basically 0, so no work is done. That's matching with option number 4. Next, question number 26. Echo is due to, so diffraction of sound, definitely not interference of sound. Refraction of sound, it's due to reflection of sound. So question number 25, answer again matches with 4. Next, question number 20. It's 25 is 4, 26 is also 4. Next, 27, let me erase the board for that. Okay, next, question number 27. So here the diagram below shows the propagation of waves which points are in same phase. So here we can see, actually this is the diagram given. This is a B, C, actually like 2 points which are at a minimum distance of lambda. is it wavelength, it will be in same phase. So where we can say F and G definitely not in same phase, C and E also not in same phase, B and G also not equal to the lambda, and B and F you can say both are at similar situation and at a distance of lambda, so they will be in same phase. Fourth is the right answer. Next question number 28. Block of mass m rests on a platform. The platform is given up and down SHM with an amplitude d. What can be the maximum frequency so that the block never leave the platform? So for that, the maximum acceleration of the block will be like d omega square. This should be equal to g, betting its weight. Then it will never leave the block, will never leave the surface. So here we are getting omega is equal to root over g by d, and omega is 2 pi f, so frequency is 1 upon 2 pi root over, this is the frequency which is matching with option number 2. Question number 29. Pi, Vi and Pf, Vf are initial and final pressure and volume of the gas in a thermodynamics process respectively. If PV power n is equal to constant, then the amount of work done. So in this, it's thermodynamic process is going from initial to final. So here we can draw the PV diagram for different values of, this is PV power n. So for n equal to, this is n equal to 0, pressure equal to constant, this is the process. We can start it from here. For n is equal to, let's say 1, then it will be isothermal. PV power 1 means n equal to 1, n greater than 1 it will go further, here adiabatic, so n equal to gamma, n less than 1 it will be somewhere here. So we can see out of all these, area under this graph gives you the work done. So out of all these possible cases, work done in this case is the maximum. So it's asking least or minimum. Okay, so it will be minimum for n equal to gamma. It will be minimum for this one. This is the minimum area. So that will be for n equal to gamma, matching with option number 1. Next question number 30. Here, in an isothermal reversible expansion, if the volume of 96 gram of oxygen at 27 degrees Celsius is increased to 70 liter from 70 liter to 140 liter, then the work done by the gas will be, so work done is equal to nRT ln V2 by V1. N number of moles 96 divided by 32 into R into T is 300 ln 140 divided by 70. This is coming out to be 3, so it's coming out to be 900 R ln, this is 2 is the answer, matching with, if we are converting into log, so 2.303 into 900 R into log of 2 base 10. This is the answer, matching with option number 4. Question number 31. Next, 1 mole of an ideal monatomic gas at temperature T0 expands slowly according to the law P by V equal to constant. If the final temperature is 2 T0, heat supplied to the gas. So here we can write PV power minus 1 equal to constant. This is a polytropic process. C process given by R by gamma minus 1 plus R by 1 minus this is X. So gamma, it's 1 mole of an ideal monoatomic gas. So gamma is 5 by 3 and its X is minus 1. So this solving we are getting, it's basically 3R by 2R plus R by 2, that's equal to 2R. Then heat supplied is equal to NC delta T. This is N number of moles 1, C is 2R into delta T is how much? T0 to T, so it's basically T0, so 2R T0 will be the work done, matching with option number 1, heat supplied. Question number 32. Temperature gradient in a rod of 0.5 meter length is 80 degree per meter. If the temperature of hotter end of the rod is 30 degrees Celsius, then the temperature of the cooler rod. So here this is the, it's basically 30 degrees Celsius, temperature gradient 80 degree per Celsius per meter. Length is 0.5 meters. So the total temperature difference across this will be like this multiplied by this. This is 40 centimeter, 40 degrees Celsius. Then this is hotter, which is as 30. So it must be 40 less. It will be minus 10 degrees Celsius. This is the answer matching with option number 2. Question number 33. So here it's saying the spherical ball is dropped in a long, 34, same amount of liquid with a specific gravity 0.8 calorie per gram degree Celsius at 60 degrees Celsius, and liquid with a specific gravity 0.7 calorie per gram per degree Celsius at 45 degrees mixed. Then the temperature of the mixture will be or may be. So heat released by the hotter liquid equal to heat absorbed by the cooler liquid. So it's 0.8 into it's same amount. Let's say amount is m. This is final temperature. So initially 60 minus, let's say, temperature at x, and this is equal to 0.7 into same mass into x minus 45 degree. Solving it, we are getting it x is equal to how much? 53 degrees Celsius. This is the answer matching with option number 3. Next question number 34. Okay, spherical ball is dropped in a long column of viscous liquid. The acceleration of the ball as function of time may be best represented by the graph. So in this case, long column. So finally, it will be reaching terminal velocity. Final acceleration will be 0. Initial acceleration will be somewhat, and it will keep on decreasing. So we can check the option according to that, which matching is correctly 4. Question number 35. A cable that can support a load of W is cut into 2 equal parts. Maximum load. So cable है, अगर इसका ये W load support कर रहा है, इसको cut कर देंगे. This part will be also supporting same W load, matching with option number 3. Question number 36. A satellite of mass m is in circular orbit of radius 2r about the earth. How much energy is required to transfer it to a circular orbit of radius 4r? The total energy initial is equal to minus gmm by 2r. Total energy final is equal to minus gmm by 4r. Actually it's 4r, it's 8r, radius is 4r, in this case 2r. So E2 minus E1 will be the energy required. This is gmm by 8r will be the answer, matching with option number 1. It can be rearranged gmm by multiplied by r square. This is g, so mgr by 8 is also matching with option number 1. Question number 37. Two solid sphere of different mass, radii and density rolls down a rough inclined plane under identical situation. Their time to come down is dependent on their, so time is equal to root over 2h or s by g, or let me write it a. So now a is given by g sin theta divided by 1 plus mk square. This is k square by r square. K can be written as some c times r square. So this is cancelling out. So we can see here c is another constant. It's not depending on mass, density and radius. So their time to come down, because a is independent of everything, so that's why time is also independent, because this and this both are constant for every. So it will be like all 4. It will all of these mass, radius, density done, like will not depend on either one. 38. Next question. Force of 7 I cap plus 3 j cap minus 5 k cap act on a particle whose position vector is I cap minus j cap plus k cap. What is the torque of the given force about the origin? So torque is equal to simply r bar cross f bar. R bar is the position vector given, position vector minus origin. Force given, simply substituting and solving, we are getting it answer. This is 2 I cap plus 12 j cap. This is plus 10 k cap, matching with option number 1. Question number 39. Circular disc is to be made by using iron and aluminum so that the required maximum amount of movement, the acquired maximum moment of inertia about geometrical axis. Maximum moment of inertia means the maximum mass must be shifted at far distance, and we can see in case of iron and aluminum, iron is much denser compared to the aluminum, so iron must be kept outside. So according to that, the aluminum at interior, iron surrounded to it is the correct answer, matching with option number 1. Question number 40. So here 4 kg bomb is exploded in 3 parts having mass ratio 1:1:2. Parts having same mass move in perpendicular direction with the velocity 30 meter per second. Then the velocity of the bigger part will be, this can be solved with the help of conservation of linear momentum. So it's m mass, let's say it's mass 2m, velocity 30, so momentum 30m, and momentum net resultant of this is m into 30 root 2. This must be equal to 2m into, let's say, velocity v. Solving it, we are getting it v is equal to 15 root 2 meter per second. So that is the answer, matching with option number 3. Question number 41. Water fountain on a ground, sprinkle water all around it. If the speed of the water coming out of the fountain is v, then the total area around the fountain that gets wet. So that will be like getting wet only for maximum range. So max is given by v square by g. So the area is equal to, this will be acting like a radius, pi into r square v by g square. This is matching with option number 4. Next, question number 42. A uniform chain of length L and mass m is lying on a smooth table, and 1/3 of its length is hanging vertically down over the edge of the table. If g is the acceleration due to gravity, then work required to pull the hanging part of the table. So that's equal to the change in potential energy of the hanging part. So initial potential energy with reference to the table plane, we can write initial and final it will be 0. So change in, so potential energy is equal to m 1/3 g, it's L by 3, mgl by 2. This is the initial, final will be 0, or you can write minus this. Then this is the amount of work, this is coming out to be mgl by 18. This is the answer, matching with option number 4. Next, question number 43. Okay, a block of mass, let me solve it here. A block of mass m is equal to 5 kg resting on a rough horizontal surface for which the coefficient of friction is 0.2. When a force of 40 Newton is applied as shown in the figure, the acceleration of the block will be. So in this case, this is 30 degree 40 Newton. So this will be like 40 sine 30. This is 20 root 3 Newton. Normal direction it's 50. So normal we can write balancing force in vertical direction. Normal direction is equal to 30. Mu is equal to 0.2. Friction force is equal to multiplied by mu into n, that's equal to 6 Newton. So then acceleration is equal to 20 root 3 minus friction 6 divided by mass 5. Solving, it's coming out to be 5.73 meter per second square, matching with option number 1. Question number 44. A particle is projected from the speed with the speed u at an angle 60 degree with the horizontal. Then find the speed when the particle its angle with the horizontal changes to 30 degree. So horizontal component of the speed must remain constant. So u cos 60 degree must be equal to v cos 30 degree. This implies 1/2 root 3/2 v is equal to u by root 3. Is the answer, matching with option number 3. Question number 45. Mass of a box measured by Gross's balance is 2.3 kg. The two gold pieces of mass 20.15 gram and 20.17 gram are added to the box. What is the total mass of the box? The total mass of the box is 2.3 kg. This is 20.15, so that will be equal to 0.0002015 kg, 0.0002017. This is coming out to 2.3. This is 0, 0, 4 and 0, 3, 2. This is the actually mass, but we need to answer that write the answer, final answer in terms of least number of significant figures according to the given problem. So least is 2 significant figures, so the answer in 2 significant figure will be 2.3 kg. That's the answer, matching with the option number 3. This is all about your paper MZT 04. Thank you.